A sample of n moles of an ideal gas is kept at a constant volume. The graph shows how the pressure P of the gas varies with absolute temperature T. What is the volume of the gas? An equation of the ideal gas is PV is nRT, where it's pressure, volume, number of moles, gas constant, and the absolute temperature. It means it must be in kelvins. If you meet change in temperature, it may be in kelvins or in degrees Celsius. It will be the same, but if you meet just T, it must be in kelvins. And this equation relates parameters of the gas at any moment of time. So at a moment of time where pressure is P1 and temperature is T1, we can rewrite this equation as P1 multiplied by volume, it's constant, is equal to N, it's also constant, R, and multiplied by T1. And at this moment of time where pressure is P2 and temperature is T2, it can be rewritten as P2V is nRT2, and we get simultaneous equations. We can subtract both sides to get P2 minus P1 times V is nR T2 minus T1. The second minus the first. This minus this is this minus this. So V is nR T2 minus T1 over P2 minus P1. Or if you plot a graph pressure against temperature, compare to the equation of a line, which is mx plus c, we can see that when P is y and T is x, gradient is n R over V. And what is gradient? Rise over run. So it's P2 minus P1, T2 minus T1. So it's P2 minus P1 over T2 minus T1. Hence, V cross multiplication, or V to the right up, T2 minus T1 to the left up, or multiplying both sides by T2 minus T1, multiplying both sides by V, or V goes to the right up and P2 minus P1 goes to the left down, or dividing both sides by P2 minus P1, we get the same result. So A is correct. The next. Two containers are filled with monoatomic gas of equal mass at the same temperature. One container holds helium and the other neon. The mass of neon atom is 5 times the mass of helium atom. What is the ratio internal energy of the helium gas to internal energy of the neon gas? We know that internal energy is equal to 3 over 2 number of particles. It's not number of moles, it's small n, it's number of moles, it's a number of particles, Boltzmann constant, and temperature. Temperature is constant, so it cancels, this constant also cancels, and 3 over 2 also cancels. So we get that the required ratio is number of helium particles to number of neon particles. And since mass is the same, but mass of one particle of neon is 5 times greater, so number of neon particles is 5 times less, or number of helium particles is 5 times greater. So the required ratio is 5. The next. A rigid vessel of volume V contains n molecules of an ideal monoatomic gas. The average kinetic energy of the molecules is K. What is the pressure in the vessel. We know that the average kinetic energy is 3/2 Boltzmann constant T, and the equation of the ideal gas PV is nRT, or n number of particles, Boltzmann constant, and temperature, and we need just combine these formulas. What is the pressure? So pressure is N constant T over V, and KT is 2/3 EK, so it is equal to 2/3 and EK over V. So it's B. And that's all for this question.